Sustainable assessment of ETSAV student housing using Verde tool. The student residential building of the School of Architecture of the Vallès, ETSAV, is located in the same area as the School of Architecture. The design proposal tries to maintain the equilibrium between the existing buildings, the exterior space and the student residence. The building is composed of 2 blocks arranged parallel to the street and with a wide central atrium. The building takes emphasis on the direct relationship with the campus and the adapted terrain, without lifts. The existing topography and the organization of the 2 blocks allows nearness to the ground and strengthening of the big area for campus life. The starting point of the project is to understand that this building shares the site with other buildings, and they can share the management to make it more rational and efficient. The proposal raises sharing the energy production systems, using existing boilers at the school, the management of the water cycle, and at the same time sharing space and uses, without the need to duplicate anything. So we understand the final proposal, its implementation in the site and the existing building connections with the university campus. The use as student residence lets us imagine strong cohabitation among the users, at individual level, thanks to the flexibility of internal flat distribution, as well as at community level, through the use of the atrium for social events. The project takes emphasis on industrialized products, the commitment to an industrialized construction project, using a single residential unit of concrete manufactured with minimum distribution, guaranteeing the habitability, simplifying the finishing, investing in energy efficiency. Moreover, it is a dry construction and therefore it's removable and recyclable or reusable. Energy efficiency. We differentiate 2 processes to reduce the energy demand in the building. Passive systems like shape, volume, implementation and composition of building materials, which will define and initiate the basic evaluation. We distinguish the following: covering the central space by an atrium with greenhouses in order to reduce the form factor without losing the qualities of space and light, increase and regulate the solar collector area, automating the atrium opening and closing and getting the control of temperature in the intermediate spaces. In the winter, a gain of temperatures between 4 and 8 degrees Celsius above the outside temperature reduces the heating energy demand. In the summer, the introduction of heat reflective screens, automatically regulated according to the intensity of sunbeams, with a shading factor of 80%, can cover all the central atrium to generate a huge shady area. 1,000 square meters of bioclimatic space very close to the comfort conditions, between 10 degrees Kelvin and 20 degrees Kelvin. Reduction of thermal conductivity from the total envelope. Cooling effect of vegetation in the central space. Cross-ventilation in all units. Prefabricated units with a lot of thermal mass inside that allow passive free cooling at night. Green facades with sunscreens and creepers. Green roof, which protects against sunbeams and performs the function of cistern to collect rainwater. Active systems for energy saving. Centralization of all campus facilities. Hot water production with micro-cogeneration. Air distribution through fan coil. The energy simulation has been obtained by Calena VYP, a recognized program for the Spanish energy certification. The building obtains a B-level certification with an emission of 8.10 kilos of carbon dioxide per square meter per year. Energy demand for heating and cooling is reduced by 35 and 52% respectively over the reference building, and also reduces consumption and carbon dioxide emissions. The project incorporates a system to reuse rainwater and greywater, each of which are used for a different function. Rainwater, collected through the green roof of the building, is used for irrigation. The proposed storage system is a 6 cubic meter tank. The water need for irrigation, estimated according to garden coefficient method, is 345 liters per day. The storage of rainwater can ensure to cover the irrigation water demand. The grey water from showers is reused for toilets. The use of industrialized material allows the improvement of the sustainability of the building for different reasons. Prefabrication and standardization allow the reduction of the construction waste almost completely. It is possible to avoid 95% of waste production in the construction phase. 65% of the total weight of dry construction. Assembly is achieved thanks to a serial construction system. The EMI system by Compact Habit achieves the construction of the building with only one typology. 86% of the total weight of materials employed a local product, in order to reduce the emissions during the transportation. It is possible reducing the carbon dioxide emissions up to 90%. A concrete structural stackable model which will be reused at the end of its life. A dry construction system with renewable, recycle and recyclable materials. 100% of the dwelling units achieve the minimum values of natural lighting fixed on 2% of daylighting factor. Moreover, all units guarantee good ventilation of space through cross-natural ventilation. The interior space is free and flexible, and every unit is provided with a balcony as intermediate space between interior-exterior, private-public, to meet with other students and socialize. The project has been evaluated by Verde tool, developed by GBC España. This tool allows the evaluation of new construction, residential and office buildings, and it is planned to permit assessment of the building on the life cycle. Verde was developed from regionalization process of sbchallenge. It is focused on the integration of Spanish and European regulatory standards, e.g., the approval of the new building code in Spain, CTE Código Técnico de la Edificación, and the implementation of the Energy Performance of Building Directive, EPDB, have shaped the handling of the representation of building energy performance results. The Verde assessment is based on building impact analysis, calculated as impact reduction compared to a reference building. The list of impacts was defined in accordance with CEN/TC 350 WG1 Assessment Environmental Building and Calculation Proposal. It's important to note that the construction also has been evaluated by Ministry of Switzerland. It has recently received the provisional acceptance according to satisfy the standard level. The final results are very interesting in this case, so with a simple strategy we can construct a very efficient building. Finally, the building obtains 2.75 points out of 5 total and 3 leaves.